Hello, my name is Bob, and I'm a tutor at Raritan Valley Community College's Academic Support Center. This is the second session of our modules looking at the TI-83 and TI-84 graphing calculator. In this session, we've been looking at how the calculator can be used for statistics. This is the second module of session 2, and we're going to look at how the calculator can help us when we have discrete random variables. In this module, we're specifically going to look at factorial and how we can calculate it. We're going to look at the binomial coefficient and the combinations rule, and again how to calculate those using the calculator. We're going to figure out how to calculate the binomial probability formula called P of x equals x. We're going to graph a probability histogram. We're going to calculate the mean and standard deviation of a binomial random variable. And we're going to use some special functions called Binom PDF and Binom CDF to calculate P of x equals x. So let's get started. First, let's just take a look at factorial. And the definition of factorial is k factorial equals k times k minus 1 times k minus 2 on down until you get times 3 times 2 times 1. And there's a special definition. 0 factorial is 1 by definition. Let's take a look at an example. Suppose we had 5 factorial. We could calculate 5 factorial by multiplying 5 times 4 times 3 times 2 times 1. Let's do that on our calculator. I'm going to clear the calculator, and we're going to hit 5 times 4 times 3 times 2 times 1 and hit enter, and we can see that 5 factorial is 120. Well, there's a simpler way to do that. We can hit the number 5, and then we're going to hit the math key. We're going to scroll to the right over to the probability function, and you can see that the fourth function down is the exclamation point or the factorial sign. We're going to scroll down to that and hit enter, and now we have 5 factorial on our screen. We'll hit enter again, and you can see that 5 factorial is 120. A much faster way of calculating it if you've got to calculate a much bigger factorial. Why don't we pause here and let you try a couple on your own? Why don't you try 6 factorial and 0 factorial, and just verify that 0 factorial is in fact 1. Welcome back. Now we're going to talk a little bit about the binomial coefficient. The binomial coefficient equals the number of possible combinations of x objects selected from a collection of n objects. So for example, suppose we had 5 coins, and we wanted to see how many ways we get 3 heads out of it. We could write that as parentheses 5 over 3 parentheses. All right. Another way of writing that is as 5cx, and that's using the combination formula at the bottom of this little screen. Let's take a look. You can see on the next screen that I've gone and taken 5 coins, a $50, a quarter, a nickel, a dime, and a penny. And you can see that we found 10 different ways of coming up with 3 heads. Well, let's use our formula and see if the formula comes up with the same answer. Our formula would be parentheses 5 over 3, and we would do that as follows. We would take 5 factorial, and we would hit the math key, scroll over to probability, and scroll down to 4 to get the factorial, divided by, we'd put in a parentheses so we could get the order of operations correctly. X in this case is 3, and we need the factorial sign, so we hit math, scroll over to probability, scroll down to the factorial sign, times, and then in parentheses again, 5 minus 3, 3, closing parentheses. We need a factorial sign, math, probability, factorial, and in the final closing parentheses, hit enter, and you can see, yes, in fact, the formula gives us 10 different ways of coming up with 3 heads on 5 coins, just as we saw in our pictorial example. So there's another way to do that calculation of 5 coins and 3 heads, and that is to use the combinations calculation that's built right into the calculator. So let's try that. Let's go down to a new line. We'll clear that last line off. And what we're going to do is hit 5, which is the number of coins that we have, and then we hit math and scroll over to probability, And you can see the third item down is NCR. We're going down to that NCR function. Okay, and we want 3. And if we hit enter, you can see that 5 coins in combinations of 3 gives us 10. So there's another way of doing that calculation. So why don't we stop for a second? And I'm going to let you do some calculations on your own. Why don't you try to calculate the number of ways that you can roll 2 6s on 5 dice? And why don't you also try the number of ways that you can get 4 heads on 5 coins and see what answers you get. And we'll be right back. Welcome back. Now let's talk about a Bernoulli trial. In a Bernoulli trial, we need 3 different things. First, we need for there to be 2 outcomes defined as success or failure. Second, each trial must be independent of every other trial. And third, the probability of success must be constant from trial to trial. So let's look at an example. In our coin toss example, where we were looking for 3 heads and 5 coins, we would define success as a head and failure as a tail. Each trial is independent because what we get on the $half does not influence what we get on the quarter, for example. And the probability of success is 50% in each of the coins, no matter which coin we toss. Let's try another example. Suppose we looked at dice, and we wanted to roll a 6 versus not a 6. In this case, a success would be rolling a 6, and a failure would be rolling a 5, a 4, a 3, a 2, or a 1. Each dice is independent of every other dice, and the probability of success is constant. It's 1 out of 6 for each dice. Now, in our book, Weiss on Introductory Statistics, he talks about creating a tree diagram. So we've created one here on the chart. And you can see on the first roll of the dice, we can have a 6 with a probability of 1 out of 6, or not a 6, which has a probability of 5 out of 6. On the second dice, we can have a 6 or not a 6, and again, the probability is 1/6 or 5/6. And the same thing on the third dice, a 6 or not a 6. So if we look at the outcome 6, 6, 6, the probability is 1/6 times 1/6 times 1/6, or 0.0046. If we look at 6, 6, not a 6, then the probability is 1/6 times 1/6 times 5/6, or as a decimal, that would be 0.0232. And we can go on down the chart until we get to not a 6, not a 6, not a 6, and that probability is 5/6 times 5/6 times 5/6, or 0.5787. Weiss then converts that to a probability distribution table where he looks at the number of 6s, 0, 1, 2, or 3, and puts the probability next to each of those. Well, wouldn't it be nice to do that on the calculator? What we need is some sort of formula that allows us to calculate that probability directly. Fortunately, we have one. It's called the binomial probability formula. The binomial probability formula, P of x equals x, is the binomial coefficient n over x times p to the x, which is the probability of success raised to the power of the number of successes, times 1 minus p to the n minus x, or the probability of failure raised to the power of the number of failures. Let's use the calculator to create a probability distribution table for the number of 6s that can be thrown with 5 dice. And the way we're going to do that is we're going to turn our calculator on, and we're going to go to the stat function. And we're going to edit the list, so we'll press enter. And you can see we have some data in there from a prior calculation, so we'll scroll up to L3 and clear it, and scroll back down. We'll scroll over and up to L2 and clear it, and go back down. And then we're going to scroll over to L1 and clear it, and go back down. And now we're going to put our data in. Now in L1 is the number of 6s that we can throw on 5 dice. And we can throw 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, or 5, enter. The most we can throw is 5 6s on 5 dice. Now in column 2, we'd like to have the number of combinations of 0 6s on 5 dice, 1 6 on 5 dice, etc. We can do that with our binomial coefficient. So we're going to scroll up to L2, and we're going to set L2 equal to 5, which is the number of dice. And now we're going to hit Math and scroll over to Probability. And you can see that third function is NCR, which was our abbreviated combination function. We're going to hit Enter. And now we need the number of successes. Well, that's in L1, so we're going to put second L1 on there and hit Enter. And now you can see that for 0 6s, there's only one way to roll that. For 1 6, there's 5 ways to roll it. For 2 6s, there's 10 ways to roll it. For 3 6s, there's 10 ways to roll it. For 4 6s, there's 5 ways to roll it. And for 5 6s, there's 1 way to roll it. Now in column 3, let's calculate the probability. Well, we're going to scroll up to L3, and the first thing we need is the number of combinations. Well, that's in L2, so we're going to take second L2. We're going to multiply that by the probability of success. In this case, our probability of success is 1 out of 6. So we're going to do parentheses 1 divided by 6, closing parentheses. And we're going to raise that to the power of the number of successes. Well, the number of successes is over in column L1. So we're going to hit second L1. Now we're going to multiply that times the probability of failure, which is parentheses 5 divided by 6, closing parentheses, and raise that to the power of the number of failures, and we're going to do that as parentheses 5 minus the number of successes, and remember that's over in L1, so we're going to hit second L1, closing parentheses, and hit enter, and we can see the probability comes out 40% for 0 6s, 40% for 1 6, 16% for 2 6s, 3% for 3 6s, 0.3% for 4 6s, and 0.0001% for 5 6s. Notice the happy accident that the probability of 0 6s and 1 6s are exactly equal. That doesn't happen very often, but in this case it did. Well, now we've created that probability distribution table that we saw in Weiss. Now, one thing that we could do is try to do a histogram. And we remember back in the first module on statistics, we did a histogram by hitting a stat plot. So we're going to do that here. We're going to hit second stat plot, and we're going to put it in plot 1, so we'll hit enter. Now you can see that my plot 1 is already turned on, but I'll scroll over to plot off and hit enter, and you can see now it's off. Scroll back to on just to show you how to turn it on and off. We're going to scroll down to type, and I've already set up for a histogram, which is right over there. We'll hit enter there. Now, in our X list is the number of successes. Well, the number of successes is in L1, so that's great. But the frequency should be the probability, and our probability is in list 3. So we're going to hit second L3, and that's where our frequency is. Now before we left the frequency equal to be a number 1 because we had all the data just in list 1, but for this particular thing we're going to use our frequency as L3. And then we're going to hit zoom, and we're going to scroll down to stat plot, zoom stat, and hit enter. And you can see we got one big thing here. Let's see if we can fix this. We're going to go into window. We're going to set our min is 0, our max is 5. We're going to put our scale at 1, and now we're going to hit graph. And you can see there's our histogram with the two probabilities being equal for 0 and 1. Then we drop down for 2, way down for 3, and is minuscule for 4. Let's hit the trace key, and you can see there's our probability for 0. We can scroll to the right, and you can see our probability for 1. We can scroll to the right one more time, there's our probability for 2. One more time, the probability for 3. One more time, and you can see our probability for 4. Now, many times we don't need to have the whole binomial distribution table. Often we just need to know how many times, what's the probability of success of rolling 3 6s on 5 dice. Well, we can do that with a formula that's built right into the calculator. And that formula is called the binomial PDF formula. The way we get there is we hit second and then DISTR, and we're going to scroll down, or I actually scroll up. We're going to scroll up to that letter A there, which is binomial PDF, and hit enter. You can see that comes onto the home screen. And now there's a syntax for this, and the syntax is the number of trials, in this case 5, the probability of success 1/6, and the number of successes 3. Let's put those in. I hit 5, comma, 1 divided by 6, comma, and 3, and we hit enter, and you can see that we get 3%. The other thing that we're often asked is, suppose we had asked what's the probability that we had less than 4 successes, i.e. that we had 0, 1, 2, or 3 successes. That's a cumulative distribution formula, and there's a formula in the computer for that as well. we hit second DISTR. We'll scroll down this time, like I said before, to the item B, which is binomial CDF, which is cumulative. We'll hit the Enter key, and now, once again, the number of trials is 5. Once again, the probability of success is 1 divided by 6. Hit with comma, and now we're looking for 3 or less successes, and we'll hit the closing parentheses, and we can see that 99.65% of the time we will have 3 or less successes in terms of rolling a 6 on 5 dice. So that's what comes up there. Now, why don't we move on? The next thing that we're often asked to calculate is the mean of a binomial random variable. And the formula for the mean is the sum of x times p of x. So let's do that in our calculator. We're going to go back to our list function. We're going to hit stat, and we're going to hit edit. And we remember we had x in column 1, and we have p of x in column 3. So in column 4, let's put x times p of x. And we can do that by scrolling over to column 4 and up to L4. And then we're going to take second L1 times second L3. That's our xp of x, and hit enter. And now we need to add those up. And the way we do that is we hit second list. We scroll over to math. You can see that the fifth function down is sum. We're going to hit enter. We put in L4, second L4, closing parentheses, enter. And you can see that it's a 0.83 is our mean. What that means is, on average, there will be slightly less than 1/6 come up on every set of 5 rolls. That's quite a small number, much lower than we would have thought, isn't it? Of course, there's another way of calculating the mean, and that is n times p. Let's see if we get the same answer. We're going to take, in this case, n, which is 5. We're going to multiply it times p, or the probability of success, which is parentheses 1 divided by 6, and hit enter. And yes, we do get the same answer that way. Now let's calculate the standard deviation. And you can see there are 2 formulas for standard deviation of a binomial random variable. The first is the square root of the sum of x minus the mean, the quantity squared, times p of x equals x. The second is the sum of x squared times p of x equals x minus the mean squared. They both give you the same answer, but the second one is a little easier to do using the list function, so we'll use that one. So I'm going to hit stat, and we're going to hit edit. And now in column L5, what I would like to put is x squared. Well, remember our x was in column 1, so I'm going to scroll up to L5 and hit L5 is equal to column 1, second list 1, squared. And hit enter, and you can see that 0 squared is 0, 1 squared is 1, 2 squared is 4, etc. down the list. Now I need to take that column and multiply it by the probability of x equals x. Well, that's in column L3. So in column L6, I'm going to hit second L3 times second L5. Now I've got the product of x squared times p of x equals x. What I need to do is add that up now. So I'm going to go to the home screen and hit second quit. I'm going to hit second list and scroll over to math, down to the fifth function, which is sum. I'm going to sum L6, second L6, closing parentheses, and from that sum I want to subtract the mean squared. So I'm going to subtract, and my mean was, remember we calculated mean by 5 trials, so I'm going to hit parentheses, 5 trials times parentheses our probability of success, which is 1 divided by 6, closing parentheses, and that quantity needs to be squared. And hit enter, and I get 0.69444444. Now I need the square root of that number, so I hit second square root, and then I hit second answer to bring the answer back, closing parentheses, enter, and I get 0.83333333. Now, of course, there's an easier way to do that. There's a second formula, and that formula says that the standard deviation is equal to the square root of n, the number of trials, times p, the probability of success, times 1 minus p, or the probability of failure. Let's try that. we're going to hit second square root, number of trials is 5, times the probability of success is 1/6, parentheses, 1 divided by 6, closing parentheses, times the probability of failure is 5/6, parentheses, 5 divided by 6, closing parentheses, and a closing parentheses for the square root sign. Hit enter, and you can see we get exactly the same answer. So let's summarize. First, we used the calculator to calculate the factorial, and we calculated 5 factorial. Then we used the binomial coefficient, and in specific the combinations rule and the TI-83, TI-84 calculator to calculate the number of combinations that we could find. Then we used the calculator and the binomial probability formula to calculate the probability that x equals x. And we did that with the list function. Then we looked specifically at the binomial PDF and binomial CDF functions, where we calculated values when we only had to calculate 1 or 2 specific values rather than the entire table. Finally, we calculated the mean and standard deviation of a binomial random variable. This ends Module 2. Current students at Raritan Valley Community College can get additional support by coming to the Academic Support Center. The Academic Support Center is open during most school hours, and you can check the hours by going to the web, www.raritanval.edu, and looking under the tab Current Students, and under Academic Resources, look for the Academic Support Center. The Academic Support Center offers a wide variety of tutoring assistance from math and English to the sciences and various humanity courses. The Academic Support Center is there to help you.